Hello. So in this video, we're going to learn the quadratic formula and learn how to solve quadratic equations. In particular, our goal is to be able to solve quadratic equations that look like this. A quadratic expression set equal to 0. And you might think that's really limited. What if you want to set a quadratic equal to something other than 0? Don't worry, we'll show an example where we do that. But let's just dive in with the method. The quadratic formula says that if you have this A, this B, this C set equal to 0, then x is negative b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. And this is the quadratic formula. It's a messy thing. Let's make a couple of observations. First of all, in general, we're going to get two solutions when you use this formula. Addition gives us a solution, and then subtraction gives us a solution. However, we do have this square root. There's no reason that b squared minus 4ac ought to be positive. I mean, no inherent reason. So you might sometimes get complex solutions using the quadratic formula. Let's start simple. And by simple, I mean that all of our coefficients will just be in nice integers, and we don't have any complex numbers or anything like that. So let's say we want to solve 2x squared plus 5x plus 2 equals 0. Well, there's not a lot to really say about this. In a sense, it's extremely plug and play. X equals b is 5, so negative 5, plus or minus the square root of 5 squared, b squared, minus 4 times a. A is 2 here, times c. C is also 2. All divided by 2 times a. A is 2. So we just take this A, this B, and this C and plug them where appropriate into this formula. And -5 plus or minus, okay. 5 squared is 25 minus 4 times 2 is 8 times 2 is 16, all divided by 4. So simplifying that square root further, I selected these coefficients completely at random. By coefficients, I mean this A, this B, and this C. But I seem to have lucked into quite a nice situation. The square root of 9 isn't some kind of ugly decimal. It's just 3. Usually the quadratic formula is going to give us decimals. So you see how we get two solutions from this. -5 minus 3 divided by 4, -5 plus 3 divided by 4. And these simplify as what? -5 minus 3 is -8. Divided by 4 is -2. -5 plus 3 is -2. So I'm genuinely kind of stunned that we got such nice solutions from a randomly selected quadratic. -2 squared is 4, times 2 is 8, minus 10 is -2, plus 2 is 0. -2 really is a solution, and -1/2 as well. Let's do an uglier problem. Let me tear this out so that we can refer back to the quadratic formula when we need to. Let's do the problem that we failed to do earlier when we were looking at factoring. This is A, this is B, this is C, and although our coefficients are rather uglier than they were in the previous example, it's still plug and play with this formula. Maybe let me try to arrange things so that we can see both the formula and the problem. X equals -b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. And I know I'm going a little quickly, but as I said, we're just taking this A, B, and C, and everywhere they appear in this formula, we plug them in. So like, why do we have a 10 squared here? Well, it's from the B squared. B equals 10. And now we're going to take this and plug it into our calculator. So when things go wrong, they usually go wrong here. Just because this is such an ugly looking thing, there are several places you could make a mistake. The first thing to recognize is that your calculator is going to follow the order of operations. If you type -10 plus this square root divided by this denominator, you have made an error already. The calculator is going to do the division first, and then it will do this addition. What we want is for the addition to be done first. Everything that's happening in the numerator should happen, then we divide. So grouping comes before division. If we put parentheses around the numerator, we should be fine. We don't have a plus or minus key. We're just going to have to do these one at a time. So for a TI-84 plus silver and some other additions, I suppose, once you put the square root, once you type the square root in, you'll be taken under the square root. In some earlier calculators, like a TI-84, you won't be. You'll press the square root and your calculator will just create that symbol. And then you'll have to put parentheses in to know, so that your calculator knows what it's taking the square root of. But let's see now, 10 squared minus 4 times -4.9 times 7.5. Get out of this square root. What's this parenthesis? Remember, we've got the entire numerator in parentheses, so we're closing those parentheses here. Divided by, once again, you have to have parentheses. Your calculator will do order of operations, and you don't want it to do division before multiplication. So you use grouping to control that. We get negative 0.583 seconds. I'll have more to say about this. Sorry, please go away. Thank you. But first, let's get the other solution. We're going to get the other solution with less hassle than we got the first solution, thanks to the entry command. We press the blue second button, then we press enter, and that brings this back up. And now we can scroll around and edit this. And we'll turn this addition into subtraction to get the other solution. Now, what often happens when you have word problems involving quadratics is that you'll get multiple solutions, 2 solutions, but only one of them will make sense. So, when will the object hit the ground? You're throwing the object off a platform. It hits the ground here. Over here, in the second quadrant, the parabola is equal to 0, but that negative solution doesn't make sense. I mean, time has to be positive. We are, as is so often the case, stuck in the first quadrant. So we'll cross out that solution. It doesn't make any sense. The object can't hit the ground after a negative number of seconds. And we'll be left with only one solution that works. Very well. I think for time reasons, I'll end this video here and then do a second set of examples in another video, rather than try to cram them all into this one.